In this next example, we're going to find the center of mass of an actual human being. And it's going to be an approximation. I mean, human beings are very, very complicated with lots of different internal organs and different densities and different distributions. But we're going to make a pretty good approximation here. And it's going to be a human being in a sitting position. I should probably stop apologizing for my drawings, but I'll apologize one more. And to make this example even easier, we're going to kind of assume that the weight of the arms, the mass of the arms, is relatively negligible compared to the rest of the body. And we're just going to do this by approximating the center of mass of the torso, which is right here. Actually, I'll do this in a different color. So here's the torso. Okay, and it is on the x equals 0 axis, or the y-axis, right? And it is a distance of 0.39 meters up. Okay, so that's the center of mass of the torso. Then we also have the center of mass of the upper leg. Okay, and we are saying that this distance here to that is 0.17. Okay, and then we have the calf, or the lower leg over here, and we're saying that this is an additional 0.26 meters from the center mass of the upper leg, and this is also going down 0.26 meters. Okay, and so we want to find out what the center of mass of this whole being is going to be if we find the center mass of the torso, the upper leg, and the lower leg. Okay, and sometimes it's helpful to make a guess where it might be, right? Here's our extreme points, and there's basically this point right here is almost right in the middle, so it should be somewhere in this general area, right? The center of mass of this person in this configuration should be somewhere in this general area. But we don't know. We'll just use that as a check to see how well our actual answer corresponds with what we imagine it might be. All right. Now, how do I find the center of mass? Well, as I promised you in the last video, there's a little bit more complication here, because now we know that whatever that center of mass is, let's say it's here, right? There's going to be an x and a y component. So I got to do two of those equations. And again, I'll start with x, right? So my x center of mass is going to be the sum of my xi's times my mi's over my sum of all my masses, right? Okay, so now I have three particles, right? So what is the x-coordinate of the upper body? Well, the x-coordinate is 0, right? So my first one is just going to be 0 times, what is the mass of the upper, of the torso, neck, and head? It looks like it's 41 kilograms, right? Not that it matters, because that's just going to go to 0. Plus, what is the x-coordinate of our next point, which is the upper legs? Well, that's 0.17. And what is the mass of the upper legs? 17 grams, right? And then what is the x-coordinate of the lower legs? Well, we got to add our 0.17 and our 0.26, and I get 0.43 when I do that. And then what is the mass of this lower leg? Well, that is just 9.9 kilograms. Okay, I'm hoping that's not all in there, but if not, that's 9.9 there. Okay, and that's divided by all of our masses added together. So that's 41 plus 17 plus 9.9. Okay, this goes away. And now it's just simple calculator stuff. I do 0.17 times 17 plus 0.43 times 9.9 divided by all those guys added together. That shouldn't be connected, 17. Okay, that means that the coordinate of my x center of mass is going to be, if I put all that in, I get 0.11. Tell me if you get something different, right? Essentially, that's 11 centimeters. So that is going to be our x coordinate. So in other words, if our center of mass has two coordinates. The x-coordinate is 0.11 meters. Cool? Halfway there. All right. Now we got to do the same thing for the up and down. So this gives us the coordinate of the center of mass in this dimension. Now we want to find the coordinate of the center of mass in this dimension. So let's do it. We have the y center of mass is now equal to the sum of my y times my mi all over the sum of all of my masses. Okay? Well, what is the y coordinate of the torso and head and neck? Okay? Well, 0.39. So this is going to be 0.39. Again, times the mass of the torso, which is 41, right? Plus, we now have upper leg. What is the y-coordinate of that? Well, it's right on the x-axis, so the y-coordinate is simply 0. That's a piece of cake, right? Times the mass of that is 17, of the upper leg is 17. Plus, what is the y-coordinate of the lower leg? Well, it's negative, it's below the x-axis, negative 0.26. So I'm going to do negative 0.26. That's important. Signs are important here because it depends on whether, your center mass is going to be very different, whether it's negative 2.6 or negative 0.26 or positive 0.26. That's going to definitely change the center of mass of an object. And the mass, again, of the lower leg is 0.9. And all these together is 41 plus 17 plus 9.9. Okay? If I put all that in my calculator, set that equal to 0, I get a value of 0.2 meters. Okay? So what does that mean? That means that the y component of my center mass, this part of this guy, is going to be 0.2 meters. Let me know if you get the same values, and hopefully you do. If you don't, well, I'll record this video. So this, my friends, is going to be the values of the center mass of this entire person. Okay? So all the beautiful and amazing things that this person is can be replaced by this one little point. All right. This is an example of how to do center mass when you have more than one dimension. In the next example, we're going to see how to calculate center of mass when you have kind of like not individual points, but things spread out over a distance. You'll see what I mean by that in a little bit. I'll see you there.